This conference will now be recorded.
Okay. Good morning, friends. In this Business Intelligence Master Program. So in this particular session, we are going to talk about Azure data flows. Okay. So this is our first session with respect to the data flows. Okay. So anybody know what is data flows in Azure Data Factory? Anybody have any idea, friends? What is data factory? Data flows in data factory. Anybody know about that?
It's like a transformations we use.
Exactly. So as of today, what we are doing is we're just copying the data. So, but copying the data means based on control flow. We have used control activities to control our pipeline execution based on based on the source or based on the type of data we are like we have loaded data into different sources, different sinks, and we have, let's say, if we have multiple tables, we have used metadata. Without using metadata also we have copied. But ultimately whatever you do, uh, you do full load or incremental load, whatever you do, ultimately we just copied the data. Okay, let's say now what I wanted to do, I want to maybe reduce the number of columns. Maybe I want to add new columns. Let's say from source file you read 100 records, 100 columns, sorry. Okay, you have source file which has 100 columns. Let's say example, customer id, customer name, customer location, customer designation, customer salary. Okay, so customer parent name, customer education details, something like that. I have 100 columns. So out of all these things, I don't want anything. I want only customer name and a customer phone number. So how to select those two and send it to the your next activity. Okay, so example I'm giving, this is one of the transformation. Second transformation is, so once you have his phone number, you need to calculate from which location he is from. So let's say first two numbers is +91, so he is from India. So if the first two numbers is, let's say, +1, so first number is +1, so he is from US. So if the first two numbers is 44, he is from UK. So something like that I want to identify. That is the transformation. So from the existing data, I'm adding the new column. Okay, I'm adding the new column. In the new column, I'm just deriving dynamically based on the input which I have received. I am just calculating the other columns. Okay, like that example, from customer phone number, I'm calculating the customer locations. That is one of the example. Let's say you have customers information and orders information. Now you want to know which customer has placed which order. You need to join these two tables. You need to join these two tables. Okay, otherwise you have let's say, let's consider India, right? So in India you have maybe you can say uh, Andhra like customer details, and Telangana customer details, Karnataka customer details, Tamil Nadu customer details, Maharashtra customer details. So we have multiple customer details, but ultimately all these are the India customers, right? So you want to combine all this data. So we have some activities called union activities, right? So these are the different kind of a transformation. You are joining multiple data. Okay, you are splitting data based on some condition, and you are joining. Okay, you are joining the data based on some condition. Let's say if the customer id is 1 and the order placed by the customer id is 1, if these two matched, then only this customer has placed that particular order. So I want to join based on that. So maybe as we discussed previously, so based on the phone number, I'm going to calculate the extra columns. Okay, not only this, you want to do some kind of aggregations, whatever you want to do, all the transformations if you want to do. Basically, mostly before data flows comes, we will use Databricks. But Databricks is what? Coding. So all the people cannot able to write the coding, right? Because it's little bit like difficult to understand. Code means every single line you need to write it, right? But here it is very simple. It's just a drag and drop. You just visually just drag the activity. You tell from which source you need to read the data. I'm going to read the data. Then you just tell us what you want to do. Okay, you want to join two data sets. Yes, just to drag the join activity. Okay, you have a join transformation. Just to bring the join transformation to join these two data sets. So whatever is common between these two data sets, I will just take it out. Okay, something like that. If you want to apply any transformation without writing any code, then we need to go for the data flows. Okay, so in today's session we will learn what is data flows and mapping data flows actions. What are the different transformations which we have in data flows? We will talk about what each transformation will do, that also we will discuss. Then mapping data flow supported data source and sync. So how we have like let's say Salesforce, we have seen bringing data from Salesforce, bringing data from Snowflake, bringing data from REST API. We have a multiple ways to bring data. Okay, by using copy activity, we have brought the data from different sources. But when it comes to the data flows, you cannot bring the data from different sources. The supported total number of supported source and sync is 9. Total supported source and sync is 9. Okay, we have blob storage, data lake storage, gen 1, data lake storage, gen 2. Then you have uh, Azure Synapse. Okay, that is nothing but Azure SQL data warehouse. Snowflake it will support, but Salesforce it will not support, and REST API. From REST API you cannot directly transform the data. Okay, so that's why we already learned. So even though we cannot apply directly transformation, first we can use copy activity to bring data from various sources, load it into data lake storage, gen 1 or gen 2, blob storage, Azure SQL data warehouse, SQL database, Snowflake, wherever you want. Once we have data in those places, then you read this data for the transformation. Okay, so we are going to understand the total supported sources and sinks. Then data flow debug, this is very important. So interactively, okay, you want to understand what each transformation is doing, how each transformation is working, whether whatever transformation I configured, is it correct or not. So if you want to execute each transformation and check the result interactively, then you need to enable the data flow debug. What is enabling data flow debug? It's nothing but you are starting your cluster, because you might not know, but people who are attending my Databricks session, right, you already know. In Databricks, we are starting the cluster, we are creating the cluster. But in data flow debug, it's a serverless. We will not have much control on the servers, right? So everything will be managed by Microsoft. Now, data flow debug, what it means, when you enable, in backend cluster will be started. Okay, so when we started our Databricks, you will come to know, see in Databricks also you'll have a different types of clusters. One is job cluster, second one is interactive cluster. Interactive cluster means, so that will be created by you and it will keep on running the time which you have configured. If you want to make you are going to configure saying that if no job is submitted on this cluster, I want to turn off. So you're going to give some 15 minutes or 30 minutes. So if you're not submitting any job for that much time, then cluster will be turned off automatically. Okay, there is another cluster called job cluster, but interactive cluster will not turn off if you keep on executing your jobs, right? You can also configure, okay, I don't want to turn off my cluster at any time, maybe 4 hours. If I'm not getting any job, still I want to run the cluster, that you can run. But there is another type of cluster called job cluster. The job cluster, what it will do, it will execute the job and it will terminate automatically. So exactly these two things you can able to do it in a data flow debug. In data flow debug, when you are enabling your data flow debug, right? So it will ask, so what is your integration runtime? So there is a something like TTL. We are going to deep dive into what is TTL and how we have to use, when to use this TTL. Time to leave, what it means, how much time you want to wait your cluster to receive the jobs. Example, as I mentioned earlier, you have inactive time in a Databricks. Inactive time means if you're not submitting any job for about 30 minutes, your cluster will be terminated. Okay, I have configured my Databricks cluster. Inactive time is 5 hours. Even if I'm not submitting any job next 5 hours, nothing is going to happen. Keep on, cluster is going to keep on running. But can you guess it and tell me what will happen if you keep on running cluster? What will increase? I have given full clue, friends. What it will increase? If you keep running something, what it will increase? It will be a
Pricing.
disadvantage to the customers. What? Tell
Pricing.
me. Exactly. So it is going to increase the price. It is going to increase the price. That's why you need to take care. So based on the requirement, you need to enable this TTL, whatever configurations, time to leave or inactive configurations, you need to specify optimized way. If you simply give, yeah, let me just run my cluster for 5 hours. Okay, so 5 hours you need to make a payment. So it is very costly. So that's why I will tell you the optimized way to configure those things in today's session. Next, sorry, I think by mistake data flow. Yeah, next, naming rules. Naming rules means, so we are going to understand so how you need to give the name for your data flows, how you need to give the name for your integration runtime. So we already know integration runtime, linked service, pipeline, data sets, the naming convention, but the data flow naming convention. So in data flows, you are going to use something called integration runtime, right? So because we discussed integration runtime is the main component, computational infrastructure. So this IR we are going to use how to give the name for your IR when you are creating. All those things we will discuss. Okay, with respect to the demo, I will show you how to set up integration runtime for data flows. Okay, so the detailed configuration, everything you can able to do it when you are creating the integration runtime. All those things I will show you. But whatever auto resolve integration runtime which you are getting by default auto resolve integration runtime, whatever you have in data factory, that cannot be edited. You cannot edit that. If you want, you need to create a new integration runtime and you need to edit the TTL. All those things I will show you. Next, I will show you how to enable data flow debug mode. So what it will do, when you enable data flow debug mode, it will just take 5 to 6 minutes to start your cluster. Okay, so it will take 5 to 6 minutes to start your cluster in the backend. Okay, so now I will just give you one scenario. You try to analyze and tell me, friends. Let's say now, as I mentioned, data flow debug mode. If I enable, it will take 5 to 6 minutes. Okay, now I'm going to execute. I will just enable data flow debug mode, and I will submit. Maybe I will just execute my data flow activity. What will happen? It will execute my data flow activity. It will execute my data flow activity, and this cluster data flow debug, if I enable, what it will do, it is going to turn on the cluster in backend, right? This cluster will be turned off once your job execution is finished. When this case happens is when TTL is 0. When TTL is 0, now what happens, your cluster will be turned off immediately once job execution is finished. Okay, let's say now I have mentioned my, so this is the question to all of you. I have mentioned now TTL is 10 minutes. Okay, I have mentioned TTL is 10 minutes. Now data flows job I have executed. After 5 minutes, I am going to execute the another data flow. Now can you tell me my second data flow activity, is it waiting for 5 minutes or will it execute immediately? Remember, my second data flow activity is going to start executing immediately because now I have configured my TTL to 10 minutes. When you configure your TTL to 10 minutes, what will happen? Cluster will not be turned off immediately. It will wait for 10 minutes. It will wait for 10 minutes. If you are not submitting any job, then your cluster will be turned off in the back end. Now, so another scenario, let's say I have configured my TTL to 15 minutes. Now I have executed a data flow. First time when you execute data flow, it will take 5 to 6 minutes. The reason is it has to start the Spark cluster. Now, after 20 minutes, I am just trying to execute my data flow activity, another data flow activity. Can you tell me whether my second data flow activity is going to wait for 5 to 6 minutes or is it going to start immediately? If you're not clear, please let me know, friends. You understood or not? That's okay. See, I will just explain once again, try to understand the concept. The cluster is a computer, friends. Let's say this is the computer I have. So if I'm just, let's say, if I'm clicking on something, this will be active. Otherwise, it will go to sleep mode, right? In the same way, if you keep on submitting jobs, your cluster, what it will do, cluster will keep on running based on the TTL. If you say TTL is 0, when you first time submit the job, it will just start within 5 to 6 minutes. Then it will be turned off. It will be turned off immediately because TTL is 0. Time to live is 0. 0 means you are saying don't wait for anything, just turn off once your job is finished. Now, when I say TTL is 5 minutes, when I submit my first data flow activity, it will just take 5 to 6 minutes, and then it will wait for 5 to 6 minutes to receive other data flow activities. Okay, so within 3 minutes, if I submit another data flow activity, what happens is this cluster immediately it will start executing because it is not turned off. It is already keep on running because it will be available next 5 minutes. TTL is 5 minutes. With the same context, now I have a data flow debug mode which is enabled, and TTL is configured for 30 minutes. When I submit first data flow, it will take 5 to 6 minutes because that is when you start job first time cluster will start, and the TTL is 30 minutes. Now if I submit by my job at 40 minutes, after 40 minutes, now what happened already? So first 30 minutes, after first 30 minutes, cluster will be turned off. When you submit your job at like after 40 minutes, what happens? There is no cluster available. It has to create the cluster again. So in this case, what will happen? Can you guess it and tell me now at least?
It will run immediately now.
Why it will run immediately? Because first job you have data flow you have submitted and TTL is 30 minutes. Okay, you have submitted. Now what happens? It will just take 5 to 6 minutes, and it will just execute it. Okay, it will wait for 30 minutes. So within 30 minutes, it has not received any job, so it will be turned off. So after 30 minutes, after you turned off your cluster, again you are waiting for 10 more minutes, then you are submitting 40 after 40 minutes, right? So after you turned off your cluster, then you are coming back and you are waiting for, after turning off your cluster, still you are waiting for 10 more minutes, then you are submitting. So in this case, you don't have cluster available. It will just again wait for 5 to 6 minutes. Okay. So don't worry because it is first session. I am not expecting you to understand everything, but you will come to know everything. So how to set up TTL for cluster, you will come to know. I will just show you those things as well. Okay, so what is data flows? Mapping data flows are visually designed data transformations in Azure Data Factory. It's a visual, completely visual. You are not writing any code. Visually designed data transformation. If you want to do any transformation, whatever we discuss, it can be join, union, aggregations, deriving the new column, or splitting the data based on some condition, or if you want to check existence of the data, whatever you want to do, all the transformations we have, all these transformations are visually designed. You don't need to write any coding for the for transforming your data. Second one, data flows allow data engineers to develop data transformation logic without writing code. So we are not writing code, right? So all data engineers, without writing code, they can able to transform their data. The resulting data flows are executed as activities within Azure Data Factory pipelines. So we know we have different activities, right? Copy activity, stored procedure activity, for each lookup. There are multiple activities we have seen. So if you remember, in copy activity down, next to copy activity, there is a activity called data flow activity. What it will do, it will ask you which data flow transformation you want to execute. Okay, first you need to understand data flow is nothing but it's a visually designed series of transformation. You'll have a series of transformation. First you'll read the source data, then you will read the source data from two different sources maybe, or from same source you will read two different tables, and you will apply a join transformation. You will join these two tables. Final data you will write it to the sink. So there is a 4 transformation. Actually, here you need to understand there are 4 different tasks you have in the data flow activity. But when you are executing from the pipeline, you just select a data flow. This is the data flow I want to execute. Under that data flow, you have a subtask 4 or 5, right? So based on the number of transformations which you are using. Now, resulting data flows are executed as activities within Azure Data Factory pipeline that use scaled out Apache Spark cluster. So where these data flows will execute? Data flows will execute on Apache Spark cluster. Next, data flow activities can be operationalized using existing Azure Data Factory scheduling, control flow, and monitoring the capabilities. So example, let's say we have pipeline. How we have scheduled pipelines? By using schedule, tumbling window, event trigger, we have scheduled the pipeline, right? So in the same way, you can schedule the data flows also by using same thing. Control flow means we have if, filter, those things. So if you want to call the data flows based on some condition, okay, so whether if the maybe transformation starting with the sales, then I want to call the sales data flow. If the transformation is starting with orders, order transformation I want to call, something like that. You can able to control that particular flow. Finally, the execution you can able to monitor it. All the pipeline capabilities you can able to use it in a data flows. Okay, next. Mapping data flows provides an entirely visual experience with no coding required. So as I mentioned again and again, no coding is required. It's completely visual. Okay, next. Your data flows run on a ADF managed execution cluster for scaled out data processing. Okay, so who is going to manage this particular cluster? ADF managed execution clusters, meaning Azure Data Factory will manage all these things. Okay, so what it will manage? We discussed multiple times. You have an integration runtime who is going to do everything. In the same way, Spark cluster who is going to do everything. Data Factory is going to manage all these things. Okay, next. Azure Data Factory handles all the code translation, path optimization, and execution of your data flow jobs. So these are very important for you. So whatever you have visually, okay, with visual, okay, maybe you can say graphically with the help of UI, with the drag and drops, you have developed your transformation. All this transformation, respective code we need to generate in the backend. So from visual to code, that code translation will happen automatically. Okay, that is the capability of data flows, right? So data factory is going to do all these things. Data factory handles all the code translation. Next, path optimization. Path optimization means in which order these activities we need to execute to get a optimized performance, to get better performance. Okay, so in which order we need to execute this transformation to finish the job quickly. So that particular path optimization will be done next, and execution of your data flow jobs. So once code translation and in which order we need to execute the transformation activities, once that is decided, it will execute your data flow job, because these two are very important. Once you are done these two, you can able to execute your data flow jobs. You can design a data transformation job in the data flow designer by constructing a series of transformations. So you're just going to, how you will create your data flow is series of transformations. So you're going to use a multiple transformation, and you will just put some relation between all the transformation, how data should flow from one transformation to another transformation, what you need to do in each transformation. You will just put all those things, and finally you will create the data flow. Okay, next, data flow. See, so let's say in Cloud Pandit, I just implemented for SCD2. Let's say, see, so I just used some source. I just used some select. Then I used joins. Okay, I have used something called conditional split. Okay, so you have like alter row, deriving the column. I have written to the sink. Okay, I just find query to get the max key. So there are different things. See this max key, I just use this max key and whatever data I'm getting from the select, these two I have joined here. So in the same way, dim agent. So this dim agent data and whatever data I'm getting from here, so these two I'm just joining. Okay, understood. So this is how you need to do all these things. So when you create the data flow, it will look something like this. So these are the just transformations. So this is source, this is select, this is a join, this is again join, this is a conditional split, this is sync. Okay, so when conditional split, if you use, so all the unmatched record will go here, all matched records will come here, and just there is a something called branch. You can create the new branch. I created the new branch. Derive column, I have added the new column. Alter row, I want to alter each row. So I need to make sure I'm going to tell this row should be upsert, this row should be row, this row should be insert, this row should be update, this row should be upsert, something like that. I want to alter all the rows. Finally, I'm writing to the sync. So here I'm just firing some query to get the max key. Okay, I'm just reading the table here. Here I am reading the file. So these three are my sources. So something like that, you are just going to use the visual transformation. So all these particular transformation, you no need to write any code. You are just a drag and drops. Okay, it's not even drag and drops. You just right click on this, you will see all the different transformations which you have. You just have to select that particular transformation. Okay, so data flows will look something like this. Okay, next, mapping data flows to action. So first and important thing is multiple input and output. So when you look at join, so if you want to join, so join is basically performed on two different data sets, two or more. Mainly it will be performed on the two. So take the result of these two and you can join with the third one. So that's how you can do, but at a time you cannot join with three. So join need at least two inputs. That's why multiple inputs and output means join require two inputs. Conditional split, it will give you two outputs. It required a single input, but it will give two outputs. Exist, it will just, so whether you are getting data from multiple inputs or whatever, it will just check whether data is available in multiple inputs or not. Union, same, it required multiple inputs. Union may take as many as you want, as many inputs as you want, because it's just going to combine all the inputs. Lookup, so again lookup, if you want to look up onto your input, so you can able to look up onto your input data. Okay, see, join, whether you can join, so where you can join data from two streams based on a condition. So maybe condition says you want to apply join something like a left join, right join, cross join, inner join. You have a different join, so you need to tell what kind of join based on your condition. Input streams will be joined. Conditional splits allow you to route data to different streams based on condition. When I say location equal to US, so all the data will go into one flow. So all remaining records will come to the another flow. So that's how you are going to get the two outputs. You are going to route the data based on your condition. Exist, check to see if data exists in another stream. So you are going to see whether data is available in a stream or not. Union, collect data from multiple data streams. You are going to collect data from multiple data streams. Example, you have table 1, table 2, table 3. I want to union all those things, you can able to use. You want to combine. Look up data from another stream. So you want to look up onto the another stream. So let's say look up, why we have used in our pipeline to look up onto the table to get a metadata. In the same way here, we are going to look up on a input streams to see some data is available or not, something like that. Okay, next, mapping data flow actions. Next, schema modifier. So as of now we have seen how to read multiple sources and join, how to get the multiple output, right? Now schema modifier. Schema modifier means derived column. I want to add a new column. Select, maybe you want to rename the column, or what else you can do, you want to reduce the number of columns. Okay, if you want to filter out the columns, out of 100 columns I want 5 columns, you can select the 5 columns. Aggregate, basically if you want to apply any aggregation, so group by, sum, max, all those things. Surrogate key is kind of a primary key for your table. If you want to generate any primary key, then you need to go with the surrogate key. So pivot and unpivot, this pivot will convert rows into a single column. Unpivot, what it will do, it will convert your column into rows again. Okay, don't worry, we will discuss in detail. Next, window transformation is where you will define a window based aggregation of columns in your data streams. Window is basically exactly mostly like a aggregate. So by using window function also, we are going to do some kind of a partition by, and if you want to generate some row numbers, right? So to remove the duplicate records and all those things, you can go with the window. Okay, you need to, based on the window, you are going to generate row number, rank, or some other, like basically we will generate the row numbers and we will remove the duplicate records. But same thing you can able to even achieve with the aggregate. Okay, but aggregate means mostly we will do some kind of group by. Then if I want to sum up the some salaries, or I want to identify the max salary or min salary, then we will go with the aggregate. These are the schema modifier. So whatever you do, see, when you add a column, schema will change. Previously we have 4 columns, now you added 5 columns, so schema has changed. Now you are just getting some 5 columns, so you're just selecting 2 columns. Schema has changed. Aggregations, when you apply aggregations, you will not get all the data, even you will not get all the columns. You will get the only columns which you have applied, which you have used in the aggregation. Surrogate key, so it is going to add the new column. So these things also will add the columns and rows. Window, here also you are going to add the column. So that's why all these are going to change your schema. Let's say if you have 3 columns, it will just give you 4 columns, something like that. Okay, but as I mentioned, derive column you can use only for adding 1 column. No, you can add at a time multiple columns also, you can able to add. But I'm just saying this is used for adding a new column. Okay, derived column, create a new column based on existing data. So based on existing data, you are going to say, let's say what happens, you have marks, right? So when you get the marks, if you look at the 10th standard or engineering, whatever, so what happens if you are getting marks greater than 90, so grade is A. If you are getting marks greater than some 75, so some B grade. So like greater than 60, C grade, less than 60, D grade, something like that people will give. So something like that. So based on some condition, okay, based on some condition, so you have already existing data, that based on that existing data you want to derive column, so grade column. So then you can go with the derived column. Select, as I mentioned, choose a column to flow into next stream that you are running. So what columns you want to pass it to the next activity unnecessarily. So whatever columns which you don't require, don't select, because those are not useful, right? So that's how we will do in real time. In real time, what happens, we will get some 100 200 columns in a table, but we don't record all those columns, we need only 10 columns. So we are going to select only the required 10 columns. Aggregate, calculating aggregations on the stream. Okay, so whatever data is coming on that, let's say salary, I want to sum up the salary, I want to find the max salary, min salary, something like that. Surrogate C, so what it will do, it will give the unique queue. So if you ask, so can you start giving numbers from 1, and it will, what it will do, it will start giving numbers from 1 1 2 3. So based on the number of records which are receiving, surrogate key will be added to each record. This will add a surrogate key column to output streams from a specified value. Next, pivot, use the pivot transformation to create multiple columns. You have a CIDs, something like that, you will have multiple columns from unique row values of a single column. What you are doing here, you are just creating the multiple columns from the unique row values of a single column. You have a single column, from that particular single column you are collecting the unique values of that particular column. Okay, unique values of that particular column you are identifying, and you are converting those things into the multiple columns. So exactly reverse in a unpivot way to turn an unnormalized data set into a more normalized version by expanding values from multiple columns in a single record into multiple records with the same value in a single column. So do not worry if you are not able to understand pivot and unpivot, we will discuss in detail. And window transformation is where you will define window based aggregation. See, same aggregations, you understood, that's what I'm saying. So window and aggregate both you can do, but aggregate mainly we will go and use for summing, max, min. Window is basically we will use for removing the duplicates and all those things. Okay, call them in your data strips. Okay, so these are just I'm giving, these are the different transformations we have available. Next, mapping data flow actions. Final actions which are available is the row modifier. So row modifier means, let's say when you apply filter, so what happens is all data you may not get in your output. You are filtering out. Sort means you will have all the data, but data will be changed. Maybe data may be there in a ascending or descending based on the configuration that you are setting in the sort transformation. Alter row. So alter row is going to tell you, so what you want to do with all the rows, whether you want to insert these rows, you want to delete these rows, you want to update or upsert these rows. Upsert means if the record is already available, please update. If the record is not available, insert it. That is the upsert functionality. Okay, so filter, sort, alter row. Basically filter for filtering, sort is for sorting the data, alter row is basically to tell insert, delete, update or upsert. Okay, so these are the different transformations we have as of today in data flows. Okay, you understood? So these are the total transformations we have. Now mapping data flows, supported data sources. See, these are the supported data sources: blob storage, Cosmos DB, data lake storage Gen 1, data lake storage Gen 2, Azure, Azure database for Postgres SQL, Azure SQL database. Okay, managed instance, Azure Synapse Analytics, that is nothing but a Azure data warehouse, and a Snowflake. Only these are the 9 sources our data flows will support as of today. Okay, so I will show you practically now only, because when you try to create the data set, there itself it will show you this is disabled. Okay, we will see that all other sources will be disabled state. Now data flow debug, this is important. The Azure data factory mapping data flows debug mode allows you to interactively watch the data shape transform while you build and debug your data flows. So what I'm doing, so I'm just using different data flow transformations to transform my data. So after each transformation, I want to preview my data interactively. I want to check my output, I want to check my result. Then you need to turn on your data flow debug. What it means, you need to have a cluster ready, so that cluster will just execute and it will give you some part of the data for your testing purpose. Okay, next, it's a good practice to build your data flows in debug mode. Why? What happens if you do that? So that you can validate your business logic and view your data transformation before publishing your work in Azure Data Factory. Right, so we have used debug, we have created breakpoint and we have executed our pipeline, right? So why we have done the like that? The reason is we have verified whether whatever logic we have given, whether it is working or not. Right, so in the same way here, when you just use debug, what happens, it will just give you the preview. It will not do the transformation, remember. Meaning, so when you just used copy activate and clicked on debug, it will really copy the data even though you are just debugging. This debug is nothing but it is not going to write data into your sink. It will just tell you what is the expected output. So if you run this data flow, what will happen? The resultant data, what data may come in from this transformation. Okay, what is the output of this transformation if you run data flow? That kind of things you can able to preview it. You can able to preview it if you enable data flow debug. Next, the debug session can be used in both in data flow design session as well as during pipeline debug execution of data flow. Meaning, when you are interactively checking the output of each transformation in data flow, you can use this. Second way is you are going to execute this data flow from the pipeline. So there also you can use this data flow debug. Next, once you turn on the slider, so slider means I will show you. So I forgot to explain you in previous slide itself. Once you turn on the slider, you will be prompted to select which integration runtime configuration you wish to use. So as I mentioned, right? So this particular data flow debug is nothing but it's going to create the cluster. Cluster is nothing but a compute infrastructure. That compute infrastructure is nothing but a integration runtime. So what kind of integration runtime you want to use? You want to use auto resolve, or you want to create your own Azure integration runtime, but self-hosted and all will not work here. You have to use only Azure IR. Okay, so now this integration runtime, you need to decide whether you want auto resolve integration runtime or Azure integration runtime, which we have created. Okay, if auto resolve integration runtime is chosen, if you are selecting the auto resolve integration runtime, edit will not work. You cannot edit anything. So what happens? A cluster with 8 core of general compute with a default 60 minutes time to live will be spin up. Okay, what it means? See, this point is very important. A cluster with 8 core of general computer with a default 60 minutes. Okay, by default TTL, you see time to live, TTL is 60 minutes. Okay, this is the default TTL is 60 minutes, will be configured when you select auto resolve integration runtime. Okay, the reason is you don't have any option to decrease the time. Minimum time that you can take in auto resolve integration runtime is 60 minutes. Okay, how many cores I'm going to take, how many CPUs, how many threads I can able to run at a time? 8 cores. 8 cores of general compute with a default 60 minutes time to live configuration will be there. Meaning we will have a 8 core cluster, and this particular cluster will be available for 60 minutes after you ran your data flows. Okay, if you are submitting some job within the 60 minutes, this particular cluster further it will run. Otherwise, at 61st minute, your data flow, whatever cluster you have created, this cluster will be turned off. Okay, next. The session will close once you turn debug off. Once you turn debug off, your session will be closed in Azure Databricks. You should be aware of the hourly charges incurred by Azure Databricks during the time that you have the debug session turned on. So Databricks is going to charge you for the cluster that you are using. Okay. For that, you need to understand how much you are going to pay. For general computing, it will be some $0.15 per hour. If it is a compute optimized, there is a something called computation. If you want to do quickly, you have compute optimized. In that case, it will be $0.2 per hour. If it is a memory optimized means all the Spark, all the transformation, whatever, it's a Spark cluster, right? So Spark need a memory optimized because it's a in memory, right? So memory optimized are the little bit costlier. That's why it will be $0.3 per hour. Okay, so if you convert that into INR, it will be some 22 to 23 rupees per hour. Very careful. Okay, next, data flow debug. Now you see, so there are two things important when it comes to the data flow debug: integration runtime and time to live, TTL. So what is integration runtime? So in this integration runtime, you see, this is the amount of time that ADF will wait after your last data preview before automatically shutting down your debug cluster. To avoid billing for the entire TTL, you can shut down the debug session when you are finished working. So what you are going to do is, one second, there is a small issue. One second. Yeah, you see here, integration runtime. So what is integration? You see, data flow debug only supports managed Azure integration runtimes. So it only supports managed Azure integration runtime. So it will not work with self-hosted IRs and SSIS IR and all those things. Okay, data flow debug only supports managed Azure integration runtimes, and they must not be in the following regions. Okay, we know, right, when we are creating the integration runtime, so we can select the region. If you are going with auto resolve integration runtime, then it will decide the integration runtime dynamically at runtime, so based on your destination. But now if you are selecting your Azure integration runtime, if you are creating your own integration runtime, you need to configure in which location you want. So but your this particular data flow integration runtime, whatever integration runtime you are using for data flow, that should not be there in a West Central US, South India, Germany, West Central. These three are the weak data centers. That's why you should not launch your integration runtime in these three data centers. Okay, now when it comes to the time to live, so time to live means this is the amount of time that ADF will wait after your last data preview before automatically shutting down your debug cluster. So I have executed my data flow activity. So after that, when you want to turn off your cluster, when you need to shut down your cluster based on the TTL configuration, it will be turned off. To avoid billing for the entire TTL, you can shut down the debug session when you are finished working. So if you don't want to incur the charges, you don't want to make a payment, okay, I don't want to, like, I don't want to make a more payment, then you can turn off your cluster once your job is finished. But there is an optimized way when you need to configure TTL, when you should not configure TTL. You see, for pipelines with a single data flow activity, use Azure IR without TTL. TTL without TTL means TTL equal to 0 you need to use. Okay, when you have a single data flow activity. But for pipelines with a sequential data flow activities, use Azure IR with a TTL set. What it means, let's say you have multiple data flows. Data flow 1 is finished, I want to run data flow 2. If data flow 2 is finished, I want to run data flow 3. So you have multiple data flow activities. Then what you need to do, you need to configure your IR, like you need to configure the TTL, saying that, okay, I know my estimation time is to execute all my data flows is 4 hours. So I will configure my TTL to 4 hours. When I have a single data flow activity, I don't need to configure TTL. I can just disable the TTL. TTL equal to 0. I can configure it. Okay. Don't worry. So I will show you everything practically. You will come to know. So in data flow transformation, see, unique within a data flow. So what it means, you are using join or whatever you are using multiple join transformation. But each join transformation should have a unique name within the same data flow. But in another data flow, you can have a same name. Okay, meaning I have data flow 1 and data flow 2. In data flow 1, you can have a two joins. Okay, you can have a two joins, but these two join names should not be same. Okay, maybe you need to tell join, first join you can call it as a join 1, second transformation you can call it as a join 2. In second data flow, you need to say, you can again use join 1 or join 2 because there is no relation between data flow and data flow 1 and data flow 2. So both are different, right? So unique within a data flow. So name should not be same within a data flow. Names are case instance too. You can use capital J in join and small j, okay, but it's a case instance too. So that's why you need to be careful. Data flow transformation names can only contain letters and numbers. You should not use any special characters. When you are giving the name for your data flow transformation, name should be formed with a letter and a number, and all the transformation should start with a letter, not a number. The first character must be a letter. When it comes to the integration runtime, we talked about this, but anyhow, we are going to create integration runtime again now. So that's why I'm talking about this. Integration runtime, unique within a data factory, names are case insensitive. So unique within a data factory. So same name you can use in another data factory, but with same name, you cannot use a multiple integration runtimes within the data factory. Okay, integration runtime name can contain only letters, numbers, and the dash. Here, when you are creating integration runtime, it supports the dash. The first and last character must be a letter or number, not a dash. Okay, understood, friends? These are the slides I have. Let me just Okay, you see I have a portal.azure.com I have opened. Now first thing we need is data factory. Okay, let's click on data factory. So I'm not going to do any data flow transformation today. So let's see how you can create your integration runtime, how to enable the data flow debug, and then TTL, how to configure all those things. For that, we need to create the data factory. Okay, so let's click on create new. You can say cloud BA master. Click OK. Come down east to west 2. Here you can say cloud and PDF meter. Data flow ADF filter, it should be available. Data flow ADF filter, click git configuration, configure git later, click review plus create. Click create. Okay, let's wait for 1 minute, it will be available. So data factory is ready. Now just click on yes, click author and monitor. Okay, let me just maximize these things. Okay, fine. And now I am here. So let's go to the author tab. So we know about all these things, right? Already. Now to create a data flow, there are multiple ways. One is just click on here, click on data flow. Okay, that is one way. Second way is just click on data flow, click on new mapping data flow, select data flow. This is the second way. Third way is click on this pipeline, create a first pipeline. Inside pipeline, you just say data flow activity. You can drag, this is the activity. So you just say create a new data flow. So this is the third way, just select it. So there are 3 ways to start with your data flows. Okay, let me just delete the pipeline. You understood? I hope everybody understood. The first way is here, second way is from here, third way is from the pipeline. So once you create your data flow, you need to execute that data flow, right? That data flow you are executing by using a data flow activity. You can see this is the data flow activity you are going to use, and you are going to select which data flow activity. See which data flow. If you have any data flow, you are going to select. But as of now, I don't have anything, so you are not going to select. Okay, fine. Delete it. I'll come back. Now let's click on data flow. Let's try to create a new data flow, new mapping data flow. Select data flow. Click OK. Okay. Now the sources, everything I will configure. See, when you just click on data source, automatically source will be added. But now the question is, to which source you want to connect? What are the supported sources? Let's see what are the supported sources. Click on new. See 1, 2, 3, 4, 5, 6, 7, 8, 9. See, we have multiple, but these are disabled. These are disabled. You see, these are not clickable. So I mean all. Here it will show all. In this all, everything is disabled except Snowflake, Azure Synapse Analytics, a managed instance, database, Postgres, data lake store, Gen 1, Gen 2, Cosmos DB, Blob Storage. You understood? Total 9 sources it will support. Okay, fine. Now you know how to create data set. Just click new, select the data, so data set, select linked service. Those things, everything is same. Okay. Apart from that, you will have some optimizing things. You want to write data into partitions, or you want a single partition. You are inspecting. Inspecting is basically for, so all those things we will cover, but inspecting is basically to tell schema is changed. Okay, if at all schema has changed, how the schema is now. Data preview. See what it is saying. So this is the preview you want to do. Please turn on debug mode and wait until the cluster is ready to preview data. So what it is saying, so turn on debug mode, okay, and wait until the cluster is ready. So when you turn on debug mode, then cluster will create. So you need to wait until cluster is ready. But how to turn on the data flow? So without any transformation, you can turn on the data flow. Just click on this. See, this is the slider. Just click on this slider. By default, it will show you auto resolve integration runtime. Time to live is 1 hour. This is what I have mentioned. The auto resolve integration runtime configuration is 8 core mission you will get, 8 core single node cluster you will get. So 1 hour time to live. Okay, just click OK. So then what happens, it will turn on, but I don't want to turn on, click no. Okay, now if you want to turn on, just click on that. So see, you don't have any like less than 1 hour, you cannot configure 1 hour, 2 hours, 4 hours. But I want to configure for 10 minutes or something. How it will, how can I do that? Right? So for that, don't use this. Come back to manage tab. Go to integration runtime, click new. Okay, so let me just tell you one thing. Just click on this auto resolve integration runtime first. Go to data flow runtime. See, it's a general purpose as we discussed in the slides. It's a 8 core. So 4 plus 4, total 8 core. Okay, 8 core single node cluster. And time to live, here it will show 0 minutes, but by default, you are going to select a 60 minutes. If you want to configure, by default, you are going to configure for 60 minutes. Otherwise, it will be 0 minutes. Okay, so if you want to configure, you have to configure 60 minutes, otherwise it will be 0 minutes. 0 minutes means cluster will be turned off after executing your job. So that will happen immediately. But if you configure for 60 minutes, then cluster will be available for 60 minutes. But can I modify this particular auto resolve integration runtime for 10 minutes? No, that and not possible. So that's why what we need to do in that case. Okay, so it's a time to live is 0 minutes. Now I want to create a new Azure integration runtime with my own TTL. Just click on Azure and self-hosted, click continue. This is the Azure IR, click continue. So just give the name of your integration runtime 1 or whatever, you know, just a description. Type is Azure. Virtual network configuration, I'm just disabling for now, but in real time we will enable this. Okay, because we want to launch it in our own. Next, region. Auto resolve means region will be selected automatically at runtime, but I want to, maybe I want to launch it in a particular region. So then let's say I will select East US. Okay, now click on data flow runtime. You see here, so whether you want a general purpose, compute optimized, memory optimized. So Spark means mostly we will go with memory optimized because it's a in memory. Next, cores. So if you want to increase the course, you are going to increase how many cores you want, you are going to select that course. Okay, next, time to live. So whether you want 10 minutes, 15 minutes, 30 minutes, 1 hour. So how much you want, you are going to select 4 hours. Okay, whatever you want, you are going to configure here. 10 minutes, 15 minutes, 30 minutes also possible when you create your own integration runtime. But if you leave it 0 minutes, then it will execute our job and it will be turned off immediately. If I select for 15 minutes, so it will be available after executing the job. Cluster will be available for 15 minutes. If any jobs it has received within that 15 minutes, it will execute those things immediately. Otherwise, if you're submitting some data flow job after 20 minutes, so this cluster is turned off now, so it has to restart again. So for restarting, it will again take 5 to 6 minutes. Okay, so let's say I will just click 15 minutes, create it. So this is how we are going to create our own integration runtime. See, integration runtime 1 is available now. Go to the author tab. Now when you are turning on, now you see when you are turning on, click on this. So you can select which integration runtime to use. I want to use integration runtime, which is my own. Okay, so this is already configured. This is already configured. You no need to configure these things. This is already configured, right? Integration runtime 1 is already configured. So what is the configured time in this integration runtime? What is the configured time? 15 minutes we have configured. So cluster will be available for 15 minutes. Okay. You just have to click OK. Understood? Everybody understood?
Yes, Malaya.
Okay. So just you have to click on this and then click OK. Okay. What else we planned? So time to live we discussed, and integration runtime I have discussed. And there is one more thing that we planned to discuss, right? Yeah, these are the 3 things only. Yeah. So next one important thing. Okay. Now see this when you turn on, okay. But now you are getting two, like you have time to leave 2 configuration, right? So this is 1 hour. Next one is whatever you have configured in this. Okay. So how these two are related? How these two are related? When you are going to consider 1 hour, when you are going to consider the time to leave which you have configured in this. Anybody have any guess, friends? Anybody have any guess? See, this is a debug. Debug means to check the output interactively. It will consider as a 1 hour. Okay. But when I publish this particular job, then I'm running this data flows, then it will consider the TTL which I have configured inside this particular IR. Please remember the differences. So this time to live will be considered when you are debugging these data flows transformation. But whatever time you have configured within this integration runtime, that will be treated, that will be considered when you are published and running. When you published, whatever detail you configured inside this, that will be considered. But when you are just debugging activities or transformations here, it will be considered. Okay, 1 hour detail will be considered. Okay, clear? That's all, friends. That's all, friends. So from tomorrow we will see one by one transformations. So ultimately we need to understand SD1 and SD2. Before that we need to do some kind of a data cleansing, duplicate, like removing the duplicates, and we need to understand the joins, conditional split, deriving columns, what exactly what it means, each activity you need to understand. Already I have some sessions in my YouTube channel. If anybody want to attend interviews immediately, they can go through those things. Otherwise we will discuss in detail. Okay, there we don't have SD1 and SD2, but this time we will discuss each and everything. Okay, that's all for today, friends. Okay, thank you.